Hi everyone, I am going to talk about characterization of compound material of epoxy resin matrix and coconut fiber. The persons involved in the project are Darwin Moran, Carlos Nicolalde, and me, Juan Pablo Pozo. The principal and general objective is characterize the physical and mechanical properties in addition to comparing the results between the coconut fiber reinforced specimen and the epoxy resin specimen to provide greater variety within the section of materials intended for the manufacture of engineering elements. And also the particular or specific objectives are improve the mechanical properties, emphasizing the reduction in brittleness of the epoxy resin being reinforced with coconut fiber, increase the sustainability of the marker using renewable materials such as coconut fiber, and explore new applications derived from coconut fiber, reinforce epoxy resin that meet the needs of potential market, showing the benefits of using the new material. Okay, before to describe the project, we have to determine what is a compound material. It is one that is formed through the combination of two or more different components, which work together to provide properties superior to those of the individual materials. These components are known as matrix and reinforcement. The matrix is a continuous material and generally of a polymeric nature, which acts as a kind of glue to join and hold the reinforcement. The reinforcement is more a rigid and resist materials such as fibers, particles, or sheets. When the matrix and the reinforcement are combined, a composite material is obtained that combines that advantage of both components. They can offer a unique combination of properties such as a high specific strength, low weight, fatigue resistance, and durability, making them a popular choice in various industries. For our project, we choose an epoxy resin matrix. It possesses outstanding mechanical properties that make it highly desirable in various applications. Some of the key mechanical properties of epoxy resin are tensile strength, compressive strength, stiffness, toughness, and impact resistance. It is important to note that the specific mechanical properties of the epoxy resin can vary depending on the formulation and the curing process used. And also, select a coconut fiber. It is a natural material obtained from the coconut shell and has some outstanding mechanical properties. Uh, some of the mechanical properties of coconut fiber are tensile strength, flexibility, lightness, compressive strength, and toughness. It is important to consider that the mechanical properties of coconut fiber can vary depending on the quality and treatment of the material. Okay, we select both components because the composite materials that consist of a matrix of epoxy resin and coconut fiber is an interesting combination that can have several applications. Epoxy resin matrix is a thermosetting polymer that is commonly used in the manufacture of composite materials due to its mechanical properties and chemical resistance. Coconut fiber, on the other hand, is known to being strong, lightly, and having acceptable mechanical properties. By combining epoxy resin and coconut fiber, a composite material can be created that take advantage of both components. Methodology. First, we have to obtain coconut fibers from the coconut. For this, we have to heat several times the sheet of the coconut and also both the epoxy resin that have two components, the additive and the catalyst. Continue with the process. A wooden mold is made with the dimension of each sample based on ASTM standards. The correct proportion that said in the extrusion of catalyst and additive is 1:2. So for this, we took care when mix both components of epoxy resin. Then we put the epoxy resin in the mold. So first put a resin coating, after a, a coconut fiber in one sense, then another coating of resin, after a coconut fiber, and finally the resin coating. Also, we put graphite after to put the mix of epoxy resin and coconut fiber to the molding easily. According to the instruction, we had to wait 3 days to desmolding and then make test to determine what is the properties of composite material. The analysis of the results of each test will have a qualitative or quantitative approach, since two types of test tubes or specimens will be analyzed. The first with epoxy resin and the second with epoxy resin plus 35% coconut fiber. In this way, demonstrate how the reinforcement present in the matrix acts and verified its increase in properties. The first test is tension. For this test, we have to make a notch in the half of the specimen to put in the homemade machine. The tensile test was used to determine the mechanical properties of mechanical subject to tensile or tension force. It provides valuable information on the strength, ductility, and ability of the material to withstand applied loads without failure. As it is a brittle material, the expected values for ultimate stress are as follows. As I said, in order to perform the home test, the following was done. Notches were made on the sides of the specimens. This serves to hold them in a better way. After placing the specimen in their position, the masses to be placed were weights. In the budget, we began to fill the mass with a rate of 14 kilograms every 3 seconds. The mass was increasing until the material failed. After performing the tensile test, it was observed that both specimens showed a fragile behavior, and this is evident since in the data table they show very low deformation and a high tensile modulus of elasticity. Additionally, it was observed that by adding the coconut fiber to resin, the load capacity increased, and therefore the ultimate tensile strength also increased in value. Then we have a bending test. In order to do that home test, put two columns of books that must be level. Then in up of the both columns to connect those, put the specimen of composite material, and finally taste with different elements and try to deformate the specimen. As can be seen in the results of the table and graphs, the test tube that presents the greatest deflection when carried out the test is the one that contains epoxy resin. So for this test, the coconut fiber reinforcement was effective. In addition, an almost 1:2 ratio is achieved between the test tube without fiber and the one with fiber. Then we have the hardness test. Considering the data shown in the table, it is considered that the hardness obtained by the resin without any reinforcement is higher because it is constant and prevents the indenter from leaving a greater mark on the material. The problem with the test tube that is reinforced with coconut fiber is that it's not homogeneous composition, meaning that areas that are exposed and are mainly made up of coconut fiber tend to have a considerably lower hardness. With the approximation of the method applied to establish the hardness of polymers, it is verified and related by interpolation to obtain values close to reality or obtained by the quality them in the analysis of polymer hardness. Finally, is a test. For this test, the specimens were embedded and the energy absorbed by the material before rupture was quantified through the conservation of energy and neglecting the losses produced by the friction between the moving parts of the pendulum and the friction with air. The reference angle is taken with respect to an axis parallel to ground. To establish an accurate comparison, it is avoided to calculate the values such as the mass of the pendulum, the radius of the pendulum, and energy conservation system is made which it is a function of the angles that describe the position of the pendulum obtain the following expression. It is possible to determine that energy that the test tube that has coconut fiber reinforcement is capable to absorbing is more than 3.88 times that of the test tube that does not have the reinforcement. The section in which the material factor was in completely different areas for the specimen that is reinforced with coconut fiber. This began its failure from the point of impact very vertically to embedment, following a line of failures of the material's product of impurities in the coconut fiber, which can be seen in the image on the side of the test tube. Unlike the material with reinforcement, the epoxy resin test tube did not present defects in its structure, but the rupture was parallel to ground right in the area of the embedment, which allows us to verify that this test tube is his fragile mind. Conclusions: improvement of the mechanical properties. The addition of coconut fibers as reinforcements in an epoxy resin matrix improves the mechanical properties of the composite material. These properties can include higher tensile strength, higher flexural strength compared to pure epoxy resin. It also provides greater flexibility to manufacture parts with the reinforcement. This being twice as flexible, this product a reduction in the fragility of the material. It could be useful within the field of robotics to design economic parts and with a density less than steel, a low cost than aluminum alloys, and ruling of the great fragility of ceramic materials. The specimens subject to traction failed in notch because the functional as a strength concentrator. Also observing the data recorded in the tables, it can be affirmed that the coconut fiber severs and reinforcement to increase the ultimate tensile stress. I enjoy sharing with you our information of the project. That's all, and until next time. Bye.